Okay, so here we have the sum of two cubes, and here we have the difference of two cubes. I'm going to jump right into the algebraic representations of these two. I'm not going to use a visual here, but if you want, you can show actual sums of cubes and differences of cubes, as in the shapes. And I've done that in other videos, but here I'm just going to go straight into the algebra. So our two formulas that we're going to work with are a cubed plus b cubed, right? The general sum of two cubes, and cubes. Now the sum of two cubes is equal to a plus b times what? Well, a squared minus ab plus b squared, and I'll share some ways to remember this in a moment. Or we can have the difference of two cubes, so a cubed minus b cubed. And that would be what? Well, a minus b times a squared plus ab plus b squared. Okay, so there are a couple ways I think about this. The first is to realize that the first sign here and here always matches what we started with. You see here, if we are adding to begin with, we're going to add in this set of parentheses. If we are subtracting, here we're going to subtract. The next sign here is always going to be a mismatch, or the opposite, right? The idea is that if we started with adding, now we're subtracting. If we started with subtracting, now we're adding. And the last sign is, in both cases, it's always positive. So that might help you. Also notice this is a little bit different than if you expanded a times a plus b, a plus or minus b times a plus or minus b. The middle term is not 2ab. So that's one way to really look at this, but you don't need to do any of that if you're scrambling on an exam or something to remember how this works. What you can do is distribute. I mean, if you set this up and you happen to make a mistake, you'll know it right away. But if you happen to choose the right combination, right, this is what I usually do. I say, okay, well, I know it's got to be something like a minus b times some form, right, like a squared. Let's say I happen to choose the right one, plus ab plus b squared. Here, right, if I'm not sure what this applies to, I just distribute. This term gets multiplied by each of the pieces inside. So we get a to the third plus a squared b, right, plus ab squared, and then what? Well, minus a squared b minus ab squared minus b to the third. And if you just look at this, you can see what will happen, right? This piece and this piece cancel out. So do this piece and this piece. And what's left is a to the third minus b to the third. So I know right away that, oh, this formula actually tells me about the difference of two cubes. So you don't have to remember these completely. Just remember parts of them. And we could talk, I mean, we won't have time in this video, but there is a way to use a visualization technique to also remember them, right, to see what's happening. But let's just jump to the problems here. So here in the first one, we have the sum of two cubes, right? So I'll write the formula up here. And I guess if it's the day before the test or whatever, and you need to remember these two formulas, you can use those mnemonics to remember what's happening. So here, right, the mnemonic is that I start with the same sign, and then what? Well, then I have a squared, and then I have the opposite sign, and then I have the same, and then I have positive, right? So that's all we're going to be doing here, as long as we can identify a and b. So here, what is a? Well, if we rewrite this, we get 3x to the third, right? And here we have, well, 1 to the third as well. So the b term is 1, right? And the a term is what? Well, it's 3x, right? That whole thing is being cubed. So we have 3x, right, plus b. And then here we have 3x squared, or 9x squared, where you square each piece, minus 3x. And again, oops, I should go back, sorry. Here, yes, it's b, but why not put in the term for b? Every time we see b, we put a 1 in. In the middle term, we don't need to, because 1 times anything is itself, and here we have plus 1, or 1 squared. And you could stop there, right? You've factored it out. Sometimes if this piece factors nicely, you could keep going, but here I'm not going to do that. But if we absolutely needed to, we could use the quadratic formula to keep going with this to get some of our roots for this equation. Now in the next one, here we have the difference of two cubes. So it's a cubed minus b cubed, right? And we said that equals, well, start with the same sign. And then what? We have a squared, opposite sign, ab, plus b squared. So here, actually, they're highlighting a and b. A is 2x, right? This is a. A equals 2x. And here, b is equal to 5. So now, we set it up. We have 2x minus 5 times what? Well, we have 2x squared, or 4x squared, plus, well, a times b, so 2x times 5, that's 10x, plus 25, right? So here, we factored it out using the difference of two cubes. And if we wanted to, we can try and break this down further as well, but usually I think we could stop here. Alright, hope this helped.